looking at Advanced Algebra 6.1, and we're looking at examples 3 and 4. These are both word problems, and one is going to be finding a side length, and the other one's going to be finding an angle. So a couple different strategies here, and they all are going to be using trig functions to do that. So let's look at the first one. We have Rachel standing 5 meters from the base of the flagpole. We should always label things. So if it doesn't have a picture, you want to draw a picture. Here we have a picture, but I'm going to label this a little bit stronger here with my 5 meters. She looks at the top of the flagpole at an angle of 25 degrees. So that was already labeled here, but this is also called an angle of elevation. If you think of those dashed lines as like lasers coming out of her eyes, she usually looks forward, but then she changes her line of sight up to the flagpole. So those lines really signify a line of sight. Then it says if Rachel's eyes are 1.25 meters above the ground, how high is the top of the flagpole? So her height right here, 1.25 meters. Now some of these measurements we can label other places too. So like this triangle up here, this dimension is 5 meters. And if I take this over here for the flagpole, I've got part of the flagpole being 1.25 meters. I need to find this other part of the flagpole. And then I can combine those two parts together. So I'm using this triangle right here. It's going to be a right triangle because that flagpole should be standing vertical. I'm looking, the x is my opposite side from 25 degrees and the 5 meters is the adjacent side. So I'm going to be using tangent for this. So always identify what type of trig ratio you're going to be using. So tangent of my angle, tangent of 25 degrees equals the opposite side of x over the adjacent side of 5 meters. Then I want to solve this for x. You always want to be a little bit more careful if you're solving for the denominator. What you could always do to make this a little easier is you could put this tangent of 25 over 1, and you could always treat all of these as a cross-multiplying problem. So if I do this one, I have 5 times the tangent of 25 degrees would equal x. So we would use our calculator to be able to do that. If you're using your graphing calculator, make sure that your mode is in the correct position in degrees. So if I click mode, I see here that it says here that I'm in degrees. If it's in radians, you would want to change it on your calculator. So I'm just going to quit out of that screen. And so then I'm going to proceed with doing 5 tangent of 25 degrees. So my other side, so 2.33. This is in meters. So this part up here is 2.33 meters, and I have this other part of 1.25 meters, so I'm going to add those two parts together, and so I get 3.58 meters. This is my height of the flagpole, and if we look to see if that would make sense, a meter is just a little bit over a yard, and it should be taller than Rachel. It would be shorter, then our picture wouldn't quite be right, and we might be doing something incorrect within it. So this was finding a side length. We found that 2.33 meters, we added it on. The next one here, we're going to be finding an angle. So it says you're standing 12 feet from the base of a tree that's 10 feet tall. So let's label that on here. So we're standing 12 feet away. We see this picture right here of us. So we're 12 feet along the bottom, and the tree is 10 feet. We want to know this angle down here. Okay, so at what angle are you looking up at the tree? This is called the angle of elevation. The angle is measured up from the horizontal. So another angle of elevation. So with this, the 10 feet is my opposite side, and the 12 feet is my adjacent. So again, for this one, I'm using tangent. So tangent of x, some unknown angle, equals 10 over 12. Now tangent is a very popular one used with word problems, but sometimes we do have to use sine and cosine too. And whenever we're trying to find an angle, we're actually going to use an inverse because we're trying to get that angle away from this trig ratio. So in order to find x, so for our x, we're going to do an inverse of tangent. It's like undoing it. So like a square, the inverse of that is square root. Tangent would be inverse tangent. So tangent inverse of 10 over 12. Now you could find that decimal of 10 over 12 and take the inverse tangent of it. So I'm going to go back to my calculator. So my two options, I could do a second tan. Oftentimes, oops, that didn't give the second tan. Oftentimes your inverse functions on your calculator are going to be the second function. So it's 10 over 12. And this is an angle in degrees, so 39.8 degrees. I also said we could do it another way. We could divide and do 10 divided by 12. And then we could take the inverse tangent of that. So notice how this is just a decimal here. And I'm going to put that answer in here. So I do a second negative. Sometimes it's that answer in there, so I get an exact value instead of having to retype and then having some error in that. Or a lot of calculators you can arrow up and take that answer and plug it back into there. So I get that same answer of 39.8 degrees. I should get the same answer for that. So my answer for this is this angle is 39.8 degrees. I don't have to add anything to it. If I notice in this picture, I would expect this angle to be less than 45 degrees because the tree is shorter than my distance from the base. So if it was the opposite way, then I would have a bigger angle. But the picture is actually drawn pretty well to scale. But don't assume that the picture is drawn to scale. So at least with these types of problems, we can kind of see if they're going to be reasonable in our answers that we get.